Today we will discuss about building information modeling, what is briefly known as BIM or BIM. We know that each building is different and even building construction process may be different. And then when each building is designed and that is designed as per user's requirement and site locations. Therefore, even if same design is there, same building design is there, based on the site location, construction process may be different. And we also know that there are multiple authorities and agencies who make their contribution in a building. Therefore, the coordination is very essential between multiple authorities and agencies. And then there are variations which take part during construction, so that is also a fact that variations are to be considered which are carried out during construction. And then we also know that sometimes requirements change during the progress of work which we are to account for. So interdependency, if we talk in building construction, that will be based on design. Then there are large number of decisions which are dependent on multiple things, and then execution methods may be different, materials may be different. Progress get affected once these multiple authorities are there and coordination is problem. Then whole effect comes on the cost of the building and time of the completion. Therefore, coordination and timely decisions, accurate designs, they are very essential. And if they are not there, then they lead to conflicts and discrepancies. Solution, if we want to know, then in case suppose the whole project and changes can be modeled on a computer rather than on site, then the final product can be visualized through virtual construction in a computer, and that is exactly done in BIM. So this type of modeling is called BIM or building information modeling. This is defined as development and management of digital representations of physical and functional characteristics of a facility, maybe buildings or any structure. I have added two-dimensional drawings also in this definition because they are part of the requirements of the BIM. So it can be development and management of digital representations of two-dimensional drawings, and then physical and functional characteristics of a facility, say building, or maybe bridge or any other structure. If we discuss the steps, then there are basically two steps. One is virtual construction and second is actual construction. And then virtual construction proceed with actual construction, and that is the advantage. Hence, conflicts and discrepancies can be removed and project understood well to arrive at a decision. So that decision making is easier. It is said that 3D BIM is there where third dimension is space, 4D is there where fourth dimension is considered as time, and 5D is there where fifth dimension is cost, and then now we talk about 6D, 7D and all that. But let us have the discussion on 3D, 4D and 5D only so far. If we talk about the stages, then first stage is modeling, which we call it BIM or information modeling. So modeling is first, but this is preceded by many activities. Modeling is not final or first step. There are a number of steps which are taken during modeling. So modeling may be first stage, second may be estimating, say whatever has been modeled, then we can estimate, we can find out the cost. Then sequencing how the work is to be done, and then procurement of materials and site management. Benefits, if we talk from the BIM technology, then one is money saving. due to avoidance of wastage, wastage of materials, wastage of resources, manpower resources, wastage of time, wastage of efficiency, wastage of even whatever wastage of maybe resources. So time saving is there, and ultimately if we see, then it is reducing the wastage, whether it is money, manpower, materials, anything. Then basic purpose of BIM is that it will reduce the wastage, and then once it is reduced, then it will give you higher efficiency and higher productivity. Main benefits may be coordination is easier and collaboration. Ordering materials timely, we know when the materials should be required and how much material is required. So ordering materials becomes easy and it may be done on time. Increasing time efficiency, avoiding discrepancies. If discrepancies are not there, then time efficiency will automatically increase. Better chances of successful delivery of project within time and cost, and saving time in fact required in documentation, and then saving cost also. We will discuss about hospital project being constructed in New Delhi, and these slides I have taken from the presentation of Mr. J.S. Sharma from CPWD, who made this presentation. And this is just a case study which you will see that, and you will understand what is BIM. Scope was that preparation of 3D virtual construction model, and then coordination among architectural, structural and MEP services to ensure clash-free design drawings, and preparing structured request for information, RFI will talk, and then discrepancy report of all disciplines reflecting various issues using 3D BIM models developed at different stages. So this scope of work includes 3D BIM model. And then this is flow chart which was prepared for the progress of overall work, and you will see that it starts with the meetings and ultimately it goes up to the final drawings floor wise. This is 3D BIM model based on for the structural drawings, and then architectural drawings, and then MEP drawings. So these three drawings are type of drawings are important: architectural, structural and MEP. And then again for MEP drawings. Now you can understand from this presentation that number of RFIs recognized in architecture and structural only in two types of drawings were 61, and then recognized in MEP services were 51. MEP services are very important, and must take care of that, particularly in building construction, multi-story building construction. Discrepancies identified in architectural and structural drawing were as many as 78, and only in an MEP services were 66. Total discrepancies were of the order of 144. So we can understand that these discrepancies have been sorted out through BIM. Some major discrepancies identified through 3D BIM modeling along with their solution provided in the project. This is one where ramp width in the basement was not sufficient. It was considered 4 meter and fire tender could not go down, and then when this came into the knowledge, then all of solution was provided. It was increased from 4 to 5 meter. Second was as per structural drawing grade beam, you can see that was placed at distance not under the slab of the staircase, and that was the problem. Then this could have created so many problems, and then this was sorted out. You can see here. Then here you can see that wall was not aligning into the beam, and this was freely standing in fact wall, and this was seen during modeling, and then it was corrected. You can see here. Another discrepancies you can see here that basement a level of retaining wall cutout was not aligning with the pipe and partly clashing with the RCC slab, you can see. So this was taken care and correction was done, you can see here. And then you see here supply air duct was clashing with waste and rainwater pipe. So this is in services, and this could have created problem during execution if not identified earlier, and then a solution was achieved. And here you see supply air duct was clashing with false ceiling, and then this was known earlier, and once it was known, then solution was obtained. Here you see the drainage pipes were proposed at the same level and thus clashing each other. So then they were moved in the direction of 45 degree, and then clash was resolved. You see here soil and wastewater pipe were clashing with false ceiling then. And this was solved by changing the level of the false ceiling. And then this discrepancy, you can see soil, waste and rainwater pipes were running at a slope and clashing with false ceiling and not passing through cutout in RCC wall. And this was then solved and solution achieved because this could be identified before execution. Here again one pipe was at slope which was clashing with HVAC chiller pipe, and then you can see the clash was avoided after giving offset in mechanical chiller pipe. Here soil and waste pipes were running in double height area, and this you can see if this could have executed, then what could have been an aesthetic. So this was solved and then route was changed. Exhaust air duct was clashing with soil and waste pipe because of the lack of the sufficient space. The pipes at the same location, and then their levels were changed. Medical waste pipe was clashing with axial frame. This then was taken a little away, shifted to right side. This then lighting, even linear recess type LED tube lights were clashing with wall. So this then they were moved a little away. And then you see diffusers were clashing with electrical fixtures. So then this solution was achieved. Then you see supply air ducts were hanging without any support in the basement. This was achieved, and this was taken along with the columns. This is from other project where rainwater pipes were just coming in front of window, and it came in the knowledge during BIM, and so the correction was done. So basically, you see what is happening in BIM is that project manager is able to foresee the discrepancies and clashes, and that we can say the problem prior to execution through BIM. That is a major advantage. And then we can remove, and the project manager can remove the discrepancies with the discussion with concerned authorities like architects, structural designers or MEP designers, and then coordinated efforts can be done, and then the discrepancies can be removed. And classes which lead, the removal of discrepancies in classes lead to save time and money. Otherwise it takes a lot of time, and then we spoil the building also. So BIM should be used especially for complicated projects and projects having complicated services. Both complicated projects and projects having complicated services, and should be used for all multi-story structures. That is important because in multi-story structure large number of services are there. Then there is a question, which model with 3D, 4D, 5D, 6D, 7D models are there, BIM models are there, which should be selected. In my view, 3D is okay if successful construction is only the requirement. Suppose employer is there or engineer in charge or client is there who is given contract to a contractor, and contractor's requirement is to give the building within certain time and within certain cost. then 3D model may be sufficient for the employer if the time and cost is the responsibility of the contractor. 4D will be good for the contractor. Suppose EPC contract is there, then EPC contract is there, then 4D where time is also monitored and approved, and which can be changed, appropriated, appropriated for the material requirement, process requirement, methods requirement. Then 4D is good according to the requirements, and this may be helpful for the contractors and builders as they have to monitor and abide by the time. 5D I think may be helpful again to the contractors and builders who have to monitor time and cost both, because then they can monitor, they can revise their time schedule of methods and materials. So 5D will be helpful for the contractors and builders and developers. So this is what I feel that 3D is helpful for the employer who has given the contract to a contractor whose responsibility is for time and cost both, and 4D, 5D will be helpful to the developer, builder and contractors. And if we talk about 6, 7, then they depend whether those services are included in the contract. Well, thanks. I am Soni, a retired CBWD. Thanks a lot.